So I got into cancer because I developed cancer myself at the age of 28. A friend of mine also a couple of years later called Sam, she developed cancer as well. And during those two events, I did a deep dive into the research because I wanted to understand more, A, to protect myself and just try and prevent the disease from occurring again, and B, to help Sam.
Right. Yeah. Yeah.
So, and initially, because the established view is that the somatic mutations, DNA mutations, cause the disease, I wanted to find out more. My oncologist, what surprised me was my oncologist and my doctor could not actually advise me which mutations caused my particular cancer. So that confused me. So I went and did a bit more research, and then over a period of time, I began to realize that the underlying cause of cancer was unknown and that scientists were having difficulty in pinpointing aspects of the disease or explaining aspects of the disease based on the DNA mutation theory. And during that research, I also came across other perspectives and other theories, which again kind of shocked me a little bit. And I couldn't understand why these oncologists weren't explaining or highlighting that there were other theories available. And I later found out that this was really important because cancer treatment is developed from cancer theory,
Yep.
and
Yep.
there are at least 7 different theories out there.
Right. Yeah.
Um,
That really surprised me when I heard that from you, because I mean I obviously following Professor Seafried at great lengths, and it's my mission to spread the word of the professor to far and wide, and you've seen my channel and what I'm all
yeah,
about, and for you to say that there was seven other theories is just like it was a shock, to be fair.
yeah, well, it was a shock to me. There's many more than that, but I've narrowed it down to 7 to say, these are relevant to people looking at the disease. So, and the key point of that is that treatments are developed from these theories, right?
Yeah.
And what we're finding out, and what Professor Seafried points out quite succinctly, is that there's serious questions to be had about the somatic mutation theory, but we'll call it the DNA mutation theory. That's the easier
Yeah.
version of
Yeah.
it.
Yep.
Um,
I know
which
exactly what it
means,
is, and I'm sure the audience do too.
yeah, well, that means that the established theory that is supported by and subscribed to by most oncologists
Yeah.
is potentially wrong, which means that those oncologists are potentially providing treatments that are not going to be uh, as effective as they could be. And it also points out that actually, if there's other theories that identify different aspects of the cancer cell that are the underlying cause or believe them to be the underlying cause, then they have different treatment modalities, different therapeutic approaches because they're targeting something different within the cell.
Yep.
Um, so, from a perspective of a cancer patient, when you are diagnosed, you want to try to find out and understand what the best course of treatment is for you. You wouldn't stick with, if you knew how many theories there were out there, you wouldn't stick with one particular theory unless it was absolutely proven that that theory was correct and those treatments were effective. Now we've got an issue where treatments aren't particularly effective. We're struggling to just increase the survival time, let alone cure the disease. We can't actually say the word cure. So if you knew there were other theories out there with different levels of accuracy in their ability to explain cancer, you would then want to know, okay, well, what sort of treatments are associated with these theories and which theory is more accurate out of the 7? Because the more accurate the theory, the more it explains about the disease, essentially, the more likely that the theory has identified a key function of cancer and that you will be targeting that key function with that therapy associated with that theory.
Yep.
So, you well know, the metabolic theory utilizes metabolic therapy.
Yep.
Now, anyone listening to this and hasn't heard of the, the metabolic theory and the therapies associated with it would want to know what those therapies are and whether or not they can help with standard of care treatment. But as far as I'm concerned, and with my experience with Sam, my friend, who unfortunately passed away,
Yep.
she wasn't provided any information about metabolic therapy or anything about the metabolic theory. So this is what I was trying to highlight to her during my research when she developed cancer, to say, look, there's these other theories out there. They offer other treatment
Options.
options.
Yep.
So maybe we should look at these as well. We don't have to get rid of standard of care treatment because they can actually enhance chemotherapy and they can enhance other therapies. So why don't we look at these? But because the oncologists hadn't mentioned this to her, and even I think some even dismiss the relevance of the metabolic theory or the cancer stem cell theory or the tissue organization field theory, patients don't get to hear about it. And this enraged me a bit, because I could see that there was all this information out there that could possibly benefit my friend and myself and anyone else who gets cancer, but it wasn't being presented. And this made me angry, especially after Sam's passing, which
Yeah.
passed after a year.
Absolutely. And as the professor says, they don't know about it. They go to medical school, they train as an oncologist, and they're taught standard of care. I know, I'll give you my story now. I was diagnosed with colorectal cancer back in 2014, and it didn't, standard of care didn't sit well with me, because basically they were going to have me shitting in a bag for the rest of my life, and I thought there must be something different. So of course I went searching the web and found loads of alternative treatments, etc., etc. But it was all bullshit and nothing worked. And so I tried Gerson therapy, Budwig protocol, apricot kernels. You must have heard of everything, and nothing worked. So I went to standard of care in 2019 and had surgery. The oncologist that I spoke to said, yours is a rare cancer. It's localized still, even though it's the size of an apple now. Where it was the size of a fingernail when I first got diagnosed. But anyway, that's beside the point. But so I had standard of care, and I decided to, once I'd had the surgery, and I just got on with my life. But then about 6 months ago, a friend was diagnosed with lung cancer, and metastasized to lymph nodes and somewhere else. I can't remember, but I think it was his liver. But anyway, so they've put him on chemo, and basically they're going to kill him. And I looked back into Professor Seyfried's work, and so I first came across his book back in about 2015, something like that.
Okay.
But I did the ketogenic diet, but I couldn't get hold of Dawn or anything like that. So it's a Press Pulse is a drug diet combination, but a diet drug combination, should I say? So I ended up with standard of care, and then now they're going to kill my friend with standard of care, and it just absolutely infuriated me that I've got to try and save the world. I've retired due to ill health. I'm not rich by any means. I can get by, but yeah, something's got to change. And to that order, I emailed every member of Parliament in the UK today with a copy of one of the videos with Professor Seyfried talking about the system being broken, etc.
Yeah. Well, hopefully that does something. But it sounds like you've been through a similar journey with to me.
So yeah, absolutely. The whole system being broken, and the problem is that doctors are trained to do what they're trained to do. I remember taking in the one of Seafried's papers to the oncologist before I decided to have the surgery, and she just took it off me and dropped it in the bin. I must follow standard of care, and that was
Yeah, it's tough. I mean, doctors and oncologists, they, in my opinion, they want to do the best for their patients, but they're working in a difficult environment where they're restricted to what they can and can't do.
Hands are
They
tied,
have
yeah.
to follow certain guidelines, and you need the science to back up any particular protocol. So I get why the system is the way that it is, and it must be very difficult for them to see their patients go through what they have to go through. But at the same time, that they're so busy, they don't often get a chance to read the papers that are coming out. And when you've gone through that process, a lot of learning, you kind of, you're going along with the established view, the medical authority. It's difficult to change direction. It really is. So I'm really sympathetic.
Yeah. Certainly from a doctor or oncologist perspective, I get that. It's the system that's broken. It's the standard of care written in granite.
I mean, they can't really change what they want to do really until the established view changes, because they need to follow that standard of care, unfortunately.
Yeah.
So it's great. It's podcasts like yours and other people's that can present different perspectives. And I think it will be the cancer patients that will push their oncologists to look at something different and make change within the industry, which is why I wrote my book for cancer patients and the layperson, translating the science, so that it gave power to cancer patients to actually help them inform themselves about potential treatments and a different perspective of the disease. And hopefully that would push cancer patients and people to talk to their oncologists just to look at different disease.
What I said to the professor on our podcast was that I truly believe that it will be a disruption. It'll be a disruption from the bottom up, and patients will say they want metabolic therapy. The oncologists will say no. They'll look on the internet. They'll see on my website, as soon as the professor brings out dosage, timing and scheduling in the paper that's been submitted, then that's something a doctor can follow. And they'll go along to the retired doctor and say, I want metabolic therapy, and there is the paper of what we need to do. And that behind me that's a disruption curve, like Nokia was disrupted by the iPhone, like Netflix disrupted Blockbuster, like the motor car disrupted horse and carts. Like renewable energy is currently disrupting the coal-fired power stations, and why we need another nuclear plant, I don't know. But anyway, we digress into another total different thing. But I think it'll be a disruption from the bottom, and I think people that have stage 4 cancer and get over it, no disease recorded or whatever they call it, and anyway, you know what I mean. That it will be one person, and it'll snowball, and before you know it, the hospitals are going, well, we haven't seen any cancer patients in the last month.
Hopefully,
that's my view, and fingers crossed that's the way it happens, because it's certainly not going to happen from the system, because well, it's my channel, stuff it, I can say what I want. It's in 1984, as the professor talked about in one video, the fox was allowed into the hen house. And in 1984, fate loves irony. Elon says that, fate loves irony, because in 1984, the drug companies were allowed into the hospitals to help find a cure for cancer because they weren't finding a cure fast enough. And now the hospitals are run by the drug companies. You know yourself, you only have to go to the doctors and you come out with a prescription.
Yeah, the medical system is definitely based heavily on the standard of care, which is drugs at the moment. And that's one of the reasons why when I did my research, I was coming across information about alternative therapies and natural compounds, food compounds, been able to kill cancer. And I know you said you tried alternative therapies or alternative modalities, and they didn't work. I was seeing in a lot of the medical literature that you could kill cancer cells selectively with natural compounds, turmeric,
Yep.
bromelain, sulforaphane from broccoli, and even honey. And so this is well known, but I wanted to explain why. I wanted to understand why. It seemed that a lot of people in the alternative industry were promoting this type of lifestyle change and diet change, but no one could really say why it was working. And I wanted to understand why, as
Yep.
well as understand why the metabolic theory and other theories weren't being spoken about. So that's really what kind of guided me. I just had this desire to try and understand the disease more. And after I'd done a certain level of research after Sam's passing, I was just determined to just know more. And I wanted to create a booklet of the research I'd already performed to highlight that there's this metabolic theory out there. There's other theories out there. There's evidence to show that a diet change, exercise, fasting, for instance, these can have beneficial effects. So I wanted to create this booklet for family and friends, so that if anyone was diagnosed close to me, they would at least have this as a starter kit to allow them to start thinking slightly differently, not just to take standard of care treatment. And then, of course, I thought this would take me 2 years, but then it developed and developed and developed as I did more and more research in all different fields of human biology. And 8.5 years later, I suddenly developed a new theory of cancer, which I didn't expect to write prior to all this research.
Yeah. Have you published it?
It's published, published in May 2023.
Right.
So it's just been just over a year. The book's called The Cancer Resolution with a question mark. I'm not making a statement, I'm asking a question, because I think that's what science is all about. You're asking a question, we need to test this, rather than I'm right, you're wrong. I think we're all in this together, so we need to be working together. And quite often, rather than it being black and white, it's a mixture of a number of modalities and a number of theories to try and understand something as complex as this. And what I found in my research is that a lot of the disciplines within medical science, because medicine is so complex, they're siloed and they don't really communicate very well with each other. And what I've tried to do is bring all this information from many different disciplines together in order to try and problem solve this problem of cancer, try and see if I can see some correlations. And that's then culminated in this magic kind of light bulb moment, if you will, where I can explain pretty much everything about cancer, or all the main hallmarks of cancer so far, which unfortunately no theory has yet been able to explain. So my theory kind of helps to explain a number of elements that other theories don't explain. It's all one cohesive whole. So yeah, it's been a long journey.
I just have a slight problem with that, just purely and simply because if Professor Seyfried is the Messiah, then I'm a disciple, and
Sure.
and so.
But as with anything scientific, we've always got to keep an open mind, haven't we?
Yes. Oh no, absolutely, and that's why we're here, and that's why we're having this conversation.
Yeah.
Yeah,
Because
and I'm
like
open-minded. Obviously, I took standard of care, but only after I'd half looked at everything else. But anyway,
but yes, like you, I was convinced. I'd looked at the bacterial theory, the viral theory, tissue organization theory, atavistic theory, all these other theories, and then settled on the metabolic theory because it seemed quite clear to me that faulty mitochondria were a pivotal mechanism. Abnormal metabolism in cancer cells is a pivotal mechanism.
Yeah, yeah.
And I stand by that today. So in agreement with Professor Seyfried there. And for a long time, I was really promoting the metabolic theory.
Yeah, the one thing that you've got, which he doesn't really explain how the mitochondria get damaged.
That's the issue.
Yes.
So
and I fully I get that.
Being a patient and having and been thinking, you know, I want to kind of understand this more. And if I'm going to be helping family and friends, I want to be 100% sure that any particular theory is right. I don't want to be pushing, say, the metabolic theory, even though I know it will benefit people. I don't want to be saying it's right or what have you, when there's some contentions. And I've discovered some contentions with the theory, and quite a number of the scientists have contentions. And that just made me sit back in my research and think, okay, the metabolic theory is the closest to what we've got to a more accurate theory. In my estimation, it can explain at least 7 of the 10 hallmarks. Yeah, the hallmarks are really important because they define how accurate a cancer theory is, because the idea of cancer theory is to explain these hallmarks. These are the key features of the disease.
Yep.
So if you can explain, so if you basically, as a theory, you state that such and such is the underlying cause of cancer, then you have to explain each one of those hallmarks to say, well, this such and such goes damaged, and this and this is wrong, and that explains that explains angiogenesis, that explains why the cell death mechanism doesn't work. And when you can do that with evidence, you'll likely identify the underlying cause or a key mechanism, because, you know, if that does become damaged, then you can explain the disease. And then it's a case of, once you've explained that theory, in theory, your theory is plausible because you can explain all the mechanisms. And technically, the mutation theory is plausible. You know, the metabolic theory, number of these theories are plausible in theory. But then what you've got to do is you've got to look at real-time evidence.
And then unpick each particular part against
you've got to look in the cell and see, is that thing that you're saying is damaged in cancer, and is it damaged in the way that you're saying it's damaged in order to cause the disease? So for the somatic mutation theory, if they're saying that at least 12, well, between 6 and 12 mutations need to occur, and it would need to be a specific pattern of mutations to occur that affect the growth, that affect cell death mechanism, that cause angiogenesis, and all these different hallmarks, these 10 hallmarks. If they aren't mutated on a consistent basis within the tumor, then how can they be the cause of cancer? They can't be. They need to be in order to be the DNA theory to be labeled as accurate. And what we find with that theory is that the mutations found are completely random. Even within the same tumor, they're random. And with a number of cancers, they don't have any driver mutations at all. How can cancer be caused by DNA mutation if there are no mutations that are driving the disease in those particular cancers? That at least suggests those particular cancers aren't caused by mutations and something else is involved. And then you've got to ask the question, if something else is involved in those cancers, what if that something else is actually causing all the other cancers and also causing the random DNA damage that's occurring in all the other cancers? So we need to explain these hallmarks. And this is where I contacted Professor Seyfried a long time ago and asked for his advice. And he said, if you're going to write a theory, Mark, you need to explain these hallmarks. This is, you know, this is the metric you need to measure the accuracy of your theory by. So I followed his advice. And based on my understanding, the DNA theory can only explain up to 2 out of 10 of those hallmarks, just 2. Now, I've often,
but what we need is we need to all wear pink and run around the park, and we need more money. That's what we need.
I know. I think the idea is that it's so complex at the moment. Well, what you've got to say is that there's 2 options. Now that we know this, right, there's 2 options. And as I was doing my research, I was like, okay, so the somatic mutation theory explains just 2 out of 10. So it could be that DNA mutation is the underlying cause of cancer, but it's just too complicated for us to understand at the moment. We need, I don't know, a quantum computer of some kind to
Sorry,
understand this
sorry.
complexity.
That was me being ironic and a failed attempt at a joke because it's my true belief that cancer is not a genetic disease,
Sure,
and
sure.
the
But the
wearing
scientist in
pink
me
and
says we
running
can't.
round the
Yeah,
parks
the scientist in
is
me says we can't say definite 100%. I mean, the bulk of evidence is
yep,
saying that it's not. I agree with you. Um, but from a scientific perspective, you'd be looking at this evidence and going, okay, we're struggling to explain these hallmarks with the somatic mutation theory. So there's one or two outcomes here. It's either too complex and we haven't got the technology to understand it yet, or the theory is wrong. So I couldn't go down that route. I'm not a scientist, so I couldn't go down and do the lab studies. So what I could do is search the internet and try and
look at
establish
papers.
connections with the evidence. Yeah, problem solve essentially. Look at different disciplines and see if I could draw connections. So that's the state of the somatic mutation theory. It only explains 2 out of 10. The metabolic theory, under my analysis, explains at least 7 out of 10. Professor Seafried would argue that it explains all 10, but there
Yeah,
are
yeah.
contention 3, which I have an issue with. So clearly, whoever's right at that moment in time, the metabolic theory is on the right track at least, and it's not what.
What are the three that you have an issue with of the metabolic theory?
Okay, so one is immune evasion. So the metabolic theory can't explain why a tumor forms initially in the fact that the immune system fails to identify the tumor. The other one is the cell death mechanism, why the cell death mechanism no longer works. And that's
The
because,
as far as I am aware,
yeah,
from everything I must. You've seen the videos on my channel. I have watched every video that Seafried's put out, or
yeah,
if I haven't, I've tried to. Um, and
there's a lot of information.
the cell death mechanism is a function of the mitochondria,
It is
and
indeed, but
the mitochondria is damaged in all cancers. He
it
hasn't
is, yeah,
found any cancer number, structure, and function of the mitochondria is damaged in all cancers, in all major cancers, and
yeah,
they looked at all major cancers under electron microscopy, and
yeah,
found ghost when you look at a mitochondria, it looks like a spaghetti network
absolutely,
under microscopy, and number, structure, and function of the mitochondria are damaged, and therefore structure determines function. What he says is fundamental biology, and so therefore the mitochondria is not functioning. So cell death can occur because the mitochondria can't kill itself or can't kill the cell.
yeah. So Professor Seafried has said in another talk that the kill switch, essentially, which is
Yeah,
controlled by the mitochondria, no longer works. So therefore, the cell can't die, so it keeps growing out of control.
yeah.
Now, the issue I've got with that is that there are studies that show that actually apoptosis, the cell death mechanism in mitochondria and p53, is enacted once you provide the cancer cells with natural compounds. So turmeric or honey or these compounds that show selectivity with healthy cells and cancer cells. So in that moment, what we're seeing is that actually um, the cell death mechanism in mitochondria, the cancer cell that allegedly wants to survive, it's got a mind of its own. That's the idea
Yeah, yeah,
we're with, isn't it?
yeah,
It's got a mind of its own. It wants to live, and it defies all death control mechanisms. Um, but when you provide it with natural compounds that normally aid a healthy cell, the cancer cell chooses to kill itself through this cell death mechanism, which we're told can no longer function. The kill switch doesn't work anymore, right? But and yet in these studies, the kill switch actually works. So this is through the p53 mechanism, through the release of cytochrome C in mitochondria. The apoptotic cell death mechanism, which we're told shouldn't be able to work, works. And the cancer cell does something completely odd compared to what the mainstream is trying to suggest. It decides to kill itself. Now, why would a cancer cell, A, decide to kill itself when it wants to survive? That's the assumption. And B, that highlights that, and this is the first thing that made me realize, hold on a minute, maybe it's not that the mitochondria are faulty. Maybe there's some sort of suppression going on. There's some sort of suppressive mechanism, because quite clearly it seems to be operational. And if you look at the work of Professor Michael Lisanti and others, they're able to actually kill cancer cells by blocking OXPHOS, the OXPHOS pathway in mitochondria, which is the energy system pathway that Professor Seafried is saying is faulty. Okay,
Yep.
so when they actually block that pathway in especially cancer stem cells, it kills cancer. So that suggests that there's that aspect of mitochondria is working. So, and there's a number of other studies as well, such as if you look at oncocytomas are benign tumors, right? They have completely dysfunctional mitochondria. They can't even produce reactive oxygen species. The electron transport chain is blocked. And you would expect cancer to form, but they don't. They form benign tumors. That particular study that I'm referring to, which is in my book, the researchers suggest that a certain level of mitochondrial function, OXPHOS function, is required for cancer to form. So we have this contention where actually it doesn't appear as though mitochondria are actually faulty and they don't work. They are, because in many examples, it's shown that they are able to reenact cell death, and they are able to reuse the OXPHOS pathway, the energy pathway. So this really threw me out, because I was really an advocate of the metabolic theory, and I still am.
Yeah.
It threw me because I was like, well, okay, there's this evidence suggesting that something else is going on. They aren't quite damaged as as it's being suggested by proponents of other theories. So I then went on this. I needed to explain this. So I went on this journey of trying to understand and explain this. And that's where I came across evidence when I was looking at something unrelated to cancer. I was looking at immunological papers, looking at infection. And this paper mentioned that during this infectious process, cells trigger a Warburg-like effect in order to combat the pathogen. And I thought, whoa, okay, here's something that a pathogen can cause the Warburg effect. And then I came across Dr. Robert Navio's work. I don't know if you've heard of
No, I haven't.
him.
No.
So he talks about, this is really interesting, because this gets to the core element of why the Warburg effect occurs, or potentially why the Warburg effect occurs. So he talks about whenever a cell becomes damaged, it responds, and he calls it a cell danger response. So even if a toxin comes into the cell, it will respond, and it will go through 3 phases. One is to establish inflammation, to warn the immune system that it needs help. The second will be a proliferative state where it regenerates the cell. And the third state will be where it returns back to a normal state once the infection or the toxin has been removed. So you have this cycle, this healthy cycle of how a cell deals with danger. Okay. And he explains what happens with infection. When I started reading this, all the parts began to kind of fall into place. So he says, when you get an infection, say a fungal infection, the fungus is detected by the cell. What happens is the mitochondria suddenly switches off OXPHOS. It stops producing energy using oxygen.
Right.
Now, the proponents of the metabolic theory say that mitochondria stop producing energy using oxygen because they're faulty. But this cell danger response is saying mitochondria intentionally stop producing energy using oxygen because they use the oxygen to combat the pathogen by flooding the cytosol with oxygen. So the mitochondria are choosing not to produce energy using oxygen to combat the pathogen. That then forces the cell into a Warburg effect, where it uses glycolysis, the backup energy system, in order to help facilitate this killing of the pathogen or preventing it from getting into the cell. So what you've got is actually an alternative explanation for the Warburg effect, where a pathogen triggers it because the cell wants to try and protect itself. The Warburg effect is actually a antifungal or antibacterial response. Now, I was reading this and I thought, this is exactly what the Warburg effect is. This is exactly what happens in cancer. And then I thought, well,
yes, it is. But But I'll go back to what Professor Seafried says, that
Yeah.
they've looked at all major cancers and the the mitochondria are damaged.
Are the mitochondria damaged because because the interaction between the fungal pathogen and the mitochondria is causing that damage? And um, can you, if it is mitochondrial damage that is causing cancer, can you identify the specific damage? Because like the DNA theory, Professor Seafried would have to identify the specific damage that is triggering this switch in energy, right? And he, as all good scientists should do, he actually suggests that this is controversial because he couldn't find any pathogenic mitochondrial DNA mutations that could explain why the energy shift occurs. Okay, so that's one of the contentions. He does identify that cardiolipin is damaged in all mitochondria, and cardiolipin is involved in the electron transport chain and the OXPHOS pathway. So
Right.
one could argue that that could be the underlying mechanism that is causing the mitochondria not to work, and that's the reason for the Warburg effect. Okay,
Yep.
but there's also evidence, which again, Professor Seafried points out, as you know, that's why he's such a great scientist. He's not just saying he's right; he's also pointing out what's wrong with his theory, and he needs to explain this. But there's a condition called Barth syndrome, and Barth syndrome is where children are born with that exact problem, where cardiolipin and mitochondria is damaged, and the mitochondria aren't working properly, so they rely on glycolysis, essentially the Warburg effect.
Right.
But those children do not develop cancer, or it's very rare in those children. So that kind of suggests that just a switch in mitochondria to glycolysis is not an underlying cause of cancer, right? There's something else going on. So something else has to, so that, and the fact that quiescent fibroblasts and cancer stem cells, they also operate, and I think it's endothelial cells. They are highly glycolytic, so they don't use as much OXPHOS, mitochondrial energy creation, as a lot of other cells do. They're primarily glycolysis based, so
Right.
they don't form cancer as a normal function of using the majority of their energy from glycolysis. So when I was looking at this research, I'm like, okay, so there's contentions now over whether mitochondria, they are definitely damaged, but it's whether or not that damage is the cause of this switch. And because in a lot of studies, the cell death mechanism can be reenacted by mitochondria, that suggested to me that there was a suppressive mechanism going on. And then when I discovered Dr. Robert Navio's work saying that fungal pathogens can cause the Warburg effect, then that started to twig with me, because then I thought, well, okay, what happens if the fungal pathogen persists in the cell? That means that the Warburg effect will persist, okay, right?
Yep. Yep.
And
Got
that
that.
interaction would be causing random DNA damage, as evidence I've got highlights that the mycotoxins that fungi can produce causes random DNA damage. But the interaction can also cause mitochondrial damage. So what we're seeing potentially, and I'm not saying I'm right, what we're seeing potentially is there's an alternative explanation where the fungal pathogen invades the cell, the mitochondria switch their energy system off. So it looks like they're
To the Warburg
damaged.
effect, yeah.
Yeah. They are damaged because the interaction, free radicals are being produced. The fungi are fighting with mitochondria and they're damaging mitochondria at the same time. They're controlling the mechanism now of cell death. They're blocking the cell death mechanism because it benefits them to survive within the cell because they can get access to the nutrients. And the Warburg effect persists. And then, and this is where it gets interesting, because this is where I'm able to explain why certain food compounds such as honey and turmeric and resveratrol from red grapes can kill cancer cells, because they all
They
are
didn't
anti.
work for me.
Say again.
They
Oh
didn't
no.
work for me.
Yeah, there'll be many reasons why. But in the studies that show that they kill cancer cells, how do you explain this? Well, you explain this because of their antimicrobial properties, their antifungal properties. So if, say, honey goes into a cell, honey is actually glucose,
Yes.
primarily glucose. It's the food or the fuel that should be fueling the cancer. Yet this is really interesting in the sense that honey should be feeding cancer, as is proposed by Professor Seafried
Yep.
and
I
some
certainly
rest
wouldn't
of the
be on
theory.
honey.
No, but studies show that certain honeys kill cancer cells. The cancer cell chooses to kill itself. So not only does that show that the cell death mechanism is not broken, but how can a sugar-based compound be killing cancer cells? Well, honey is highly antimicrobial.
Right.
Right. So the idea is, based on my theory, is that the honey, the antimicrobial aspect of honey is killing the fungal pathogen or attenuating it. So it becomes less effective, which allows the mitochondria to then kill the fungal pathogen or regain control. And then the mitochondria is asking itself the question, am I damaged too much to carry on living, or am I going to be um, a negative effect on the host? And in that process, those cells are programmed to kill themselves in order to protect the host. And
Yep.
so the mitochondria will look at themselves and they go, right, this interaction between this fungal pathogen I've had has damaged DNA too much. It's damaged myself, mitochondria too much. We can't be repaired. So let's trigger apoptosis. And it does through the mitochondrial apoptotic pathway, which highlights that it's not actually damaged beyond repair, which suggests that mitochondria, yes, they're damaged, but that's not the reason for the Warburg effect. Potentially, the reason for the Warburg effect is because the fungal pathogen is there and the plant compound has killed the pathogen, allowing the cell to reenact apoptosis, which
And
is why I come across with this cell theory, which is the cell suppression theory.
yep, yep. So I get that, and that's okay for cells that have not got um, mitochondria that are so damaged that they
Mm.
can't switch on apoptosis.
Mitochondria are not just the only organelle or feature of a cell that can generate apoptosis. So the DNA within the nucleus can. So the p53 gene, that will trigger apoptosis.
Right.
Immune cells also can trigger apoptosis by connecting to certain receptors on the outside of the cell. So there's several different mechanisms in order to create apoptosis, and I think they're generated in that way so that if one thing goes wrong in the cell can still be triggered to kill itself. Because it doesn't make sense in evolution to have one mechanism. Because if that one mechanism does go wrong, then you're going to get loads of cancers. You're going to get loads of cells growing out of control. That's not going to be good. So this is the problem I had with the somatic mutation theory, because that's saying that the p53 gene, if that's mutated, then the cell cannot die, right? But then the metabolic theory highlights that no, mitochondria can also trigger cell death. So but then you do more research and you see that the immune cells can also trigger cell death. So if the somatic mutation and metabolic theory are correct, and the DNA within the nucleus cannot trigger apoptosis, and the mitochondria cannot trigger apoptosis because they're damaged, the immune cells can also trigger through a different pathway apoptosis
Right.
if those two don't work. So you've got all these different mechanisms that work just in case one doesn't work. So I think to say that because mitochondria are damaged, therefore that's the reason why apoptosis can't work, might be a little disingenuous in the sense that there are other mechanisms that can cause it, which is why I wanted to be able to explain all three of those. And fungal pathogens, in the sense of controlling the cell, are able to inhibit all those processes.
Yeah.
So that provides like a unique cross-platform explanation as to why apoptosis doesn't work, but then it can be reinstigated. So it seems like it's being suppressed rather than it's just damaged.
How can the professor prove it?
How can he prove? Well, he would have to show specific, like the DNA mutation theory. Proponents of the DNA mutation theory would have to show which specific damage is causing cancer. So Professor Seafried would have to show which specific damage is causing cancer. So it might be a combination. So he would probably say cardiolipin abnormalities is one, but you would need to have something else on top of those cardiolipin abnormalities uh, to help address that. But at the moment, we're not at that level. It might be Professor Seafried might actually find out that he might be right, and he might later on be able to find the specific DNA mutation, the specific mutations in
I th-
mitochondria and various other damage that could cause it. Um, and that could explain it. But at the moment, I don't think we're at that level.
Yeah, I think we need to get a three-way conversation going on this channel in the not too distant future. When certainly when he's released his paper on what, when, where, why of metabolic therapy.
Yeah,
Because one thing that I will add to everything that you've said, metabolic therapy works.
absolutely. And I
And
propose,
have you
yeah,
seen the latest video that I've put on my channel with Dennis Stacey? Did you watch
I
the
did have a
whole?
brief, yeah, I didn't listen to the whole thing, but I did have a brief look. Yes.
Oh, the first time I saw that, I was in tears, because he's as far as he's concerned, he's N of one. Of course, he's not N of one.
Mm.
There are lots of on my website. I've got a number of case studies that the professor's written up,
Yeah,
of people who, like the lady from Ohio, who was given weeks to live, was in intensive care, went to Istanbul, Turkey, to the doctors that were following his protocol, and she's now alive and well, cancer free.
mm,
Last time the professor saw a photograph was of her and her husband on vacation, as they call it in America, on vacation.
fantastic. Within my theory, I advocate for metabolic therapies, because the metabolic therapies are actually not only targeting the cancer cell, but you're actually targeting the fungal pathogen as well, because the primary fuel of the fungal pathogen is glucose, the same as the
Yeah.
cell. Now, I notice also that Professor Seafried uh, also advocates for mebendazole and fenbendazole, the
Yes,
antiparasitic
yes.
drugs.
I was just going to mention that. So, because I put a video out on X, formerly Twitter, and I watched I'm picking people's brains, and chopping up everybody's videos, and making them my own. But
Yeah.
I'm just, all I'm doing is trying to get the message out. And if somebody copyright strikes me and says, take it down, then I'll have a problem with that person, because we're trying to save the world here.
Well, from what I can tell, Vince, like you just want the truth, don't you? You're just looking to find the truth. That's
Absolutely,
what
absolutely,
scientists are
absolutely.
trying to do. But
Yeah. So Joe Tippins talks about fenbendazole, because he cured himself of small cell lung cancer with fenbendazole, and fenbendazole alone. That's
yeah,
that's the one thing that's right up your theory, if that's a saying. But so he cured himself with fenbendazole, and then the professor talks about why fenbendazole and mebendazole have an effect. He says that they use the same energy pathway of both glucose and glutamine, and he was the
yeah,
one that discovered the fact that glutamine was a fermentable fuel in cancer cells. Mebendazole, fenbendazole make it into the metabolic. So yeah, I was just saying that yes, metabolic therapy works.
it does. It does,
And
and I advocate.
Stacey's and everybody else is testament to that. Obviously, we've got an issue with the diet drug cocktail being done. 6-diazo-5-L-noreleucine is unavailable, but I do have a forum on my website, and when I did a video on, I won't say again, Don. When I had a video on Don, I mentioned the forum and the fact that I would try and get a source from China. And we've since had, so on the forum, I put China something or other, this website I found, which was a bit like Alibaba for chemicals. With the exact search term, I found a number of suppliers that would supply, and to tell them that you were doing research, etc. And if it was me, I would simply say that I was trying to replicate what Professor Seafried has done in his papers because I didn't believe it. Whatever, some sort of bullshit. Just to get a hold of it. But anyway, so long and short is a number of members of the forum and members of the channel have got a hold of it. So whether they've used it, because of course you can't go to a doctor and do metabolic therapy now. There's just two listed: the Hippocrates Research Foundation, which helped Dennis Stacey, and the other one in Istanbul, Turkey, are the only two places that I have currently listed on my website. I'm sure there are a lot more, and I'm sure if I manage to twist Seafried's arm, he'd tell me a few more that are doing the therapy. But anyway, I'll keep it up to date as much as I can. Like I say, I'm just trying to save the world.
Yeah, you're doing a fantastic job on that. And can I just go back to, if we go back to the mebendazole and fenbendazole?
Yes.
So, I agree with you with metabolic therapy. I've advocated for it as part of the theory in my book.
Yeah,
because it so targets the fungal pathogens I'm saying are the underlying cause of the Warburg effect. Now, the interesting thing is mebendazole and fenbendazole are also antifungal.
right.
Now, what I found with my research is if you look at metformin, tamoxifen, if you look at all the other off-label drugs, lovastatin, if you look at those compounds that are being used or tested for their benefit against cancer, what you see is that they're also all antifungal. So what I'm saying is, I'm not saying I'm right. I'm not saying Professor Seafried and the metabolic theory is wrong. What I am saying is that there are some contentions with the metabolic theory that I wasn't comfortable with. That led me down this path of research. And then I discovered that actually there's an alternative explanation that explains the things that can't currently be explained by the metabolic theory about why the theory occurs in the way that it does, why cancer occurs in the way that it does, through identifying fungal pathogens as the underlying cause of the Warburg effect. And then when you look at all the treatments that seem to be effective, you also find that they are also antifungal. So my question then would be, are these treatments working? Are these drugs working because they're directly affecting the pathways within the cell? I'd argue yes. But are they also effective because they're also targeting the fungal pathogen that may be, as I'm suggesting,
The underlying cause.
So I've yet to find an effective drug that's being used that isn't antifungal. This is the interesting thing about it. So the diabetic drug, which is able to restrict the blood glucose levels, to restrict the glucose going into the cancer cells, to starve them essentially, is also antifungal. Tamoxifen is also antifungal. So there's this
tamoxifen, is it? Right. Okay.
Yeah, tamoxifen for breast cancer is also antifungal in its own right. So there's an interesting correlation, and everything seems to feed into the theory that I put forward. It's just that and what I'm doing with putting the theory out there, it's got to the stage where my theory can explain all 10 of those hallmarks.
Yep.
Okay, with supporting evidence. And a theory that explains all 10 is either identified the underlying cause or has identified a key mechanism. It might not be the underlying cause, but a key mechanism. So it's at the very least worth looking at and looking into this correlation. And all I'm doing by putting it out there is saying, look, I'm not saying I'm right, but there's some very interesting evidence to suggest that fungal pathogens are heavily involved, if not the underlying cause of the disease. We need to look at it. Please test it. Please pull it apart and see what's wrong with it, because I'm only interested in truth. I'm not interested in being right. If I'm wrong, then I don't want to be telling my family and friends that I'm right, because they're not going to survive.
No, absolutely.
So my motivation is the truth, and in order to protect my friends and family and myself. So I've got no skin in the game in the sense of I'm pushing particular drugs or anything like that. I just want to know the truth, and I'm quite happy to be wrong so long as we find what the truth is in order to benefit everyone as quickly as possible. Yeah, and it's just interesting that everything you see has this underlying antifungal property and fungal connection to all the aspects of the disease that's worth looking into.
Yeah, Joe Tippins did say that he's got a Facebook group and he's been collecting success stories and some failures. He has had some failures. He said that some of the failures were just too late. They beat up by the treatments that they'd had. In other words, they were poisoned and irradiated and whatever.
It's difficult for the body to recover.
Yeah, absolutely. But he does have 3 patients who were stage 4 pancreatic, which, of course, is a death sentence, just like his small cell metastatic lung cancer was. I'd just like to try and explain what I've learned from you from my perspective for the audience.
Okay.
So basically, you're saying that it's a fungal pathogen that is causing damage to the cell and damage to the mitochondria, which is switching off oxidative phosphorylation, switching off OXPHOS, and then it remains present, therefore damaging the mitochondria to such a degree that it can't kill itself. And at that point, we get what Professor Seyfried has seen under the microscope of all major cancers, which is damaged mitochondria. So it's sort of an extension of the metabolic theory, but taken to the nth degree, as it were.
Yes, and with that, I'm able to explain a lot of other anomalies with cancer and all the 10 hallmarks. But on top of that, as I was going through my research, there are a number of other things that aren't quite explained by a number of the other theories, such as, I explained the reverse Warburg effect, the involvement of galectin-3, carcinogenesis, arginine auxotrophy. There's several other, the involvement of iron, why iron tends to cause cancer. So there's a number of things that needed to be explained. And I thought, as I was doing my research, well, these aren't currently explained. And if I want to produce a credible theory that people will listen to, I need to also explain all these things. So I also explain an extra 20 features as well.
Right.
And so it's not, I didn't just stop at the 10 because I know I'm not a scientist, and people will probably discount me, even though explaining 10 is quite an impressive thing to do. I went and did the extra 20, and there's a number of others that I explain as well, but I don't include them in the 20 list, but they're in the book. So from that perspective, I'm able to coherently explain a broad range of factors of the disease, which does suggest that there's an integral involvement of these fungal pathogens. Not only that, but Ravid Straussman has been testing samples of different cancers. And what he's found is that fungal pathogens, as well as bacteria, fungal pathogens exist in all cancers. So that's the real world data that would corroborate my theory to suggest that, because if there weren't any pathogens in tumors, then my theory falls apart, because they would need to be present in order for the tumor to grow, because they're controlling the mitochondria. Now, proponents of the DNA theory, I think some of them still believe that tumors are sterile. They don't have any microorganisms in them. Because it was only 2017 that Ravid Straussman put his paper out and highlighted that actually all tumors harbor their own microorganisms, pathogens. So this is a relatively new thing. Now, the question then is, does the tumor arise because mitochondria are damaged and these pathogens just colonize the tumor afterwards and then nothing really to do with it? Or are they actually driving the disease? So this is what really needs to be tested. And I've put forward this theory, which suggests, well, this is exactly how the first cancer cell starts. This is how it develops through, because all these conditions benefit the fungal pathogen invading the cell to cause the Warburg effect. And then it goes on from there to cause all these other aspects. And this is why iron's involved. This is why lactate's involved. This is why the reverse Warburg effect occurs. So I offer an alternative explanation for all these things that all marry together, which is quite nice in that respect. So it's definitely a plausible theory that needs. And the other thing I would say, you mentioned pancreatic cancer there. So we're talking about maybe treatments for people. I'm not giving medical advice. I'm not a clinician, so I can't do that.
Listen. Have you heard me rabble?
Yes,
when I first started.
Yeah.
I'm not a doctor. None of this is medical advice. I'm just some random bloke on the internet.
We don't want to mislead people.
This may be the ramblings of a madman.
Yeah, absolutely. I feel mad sometimes, and people certainly think I'm mad for what I've done. But I want to make sure that I'm not suggesting that antifungal drugs are the way to treat cancer, because here's the thing: even with fenbendazole, and Joe Tippin's using fenbendazole, you're not going to be able to kill all the fungal pathogens that are present. It's so complex. Fungal pathogens develop biofilms and they live within those biofilms. Antifungal drugs can't get through, and even the immune system can't get through into those biofilms to kill the fungal pathogens that are there. So they're very difficult to eliminate them. So it's not a case of, here, take itraconazole, an antifungal drug, and you'll be able to. And if the cancer doesn't die or dissipate, then it's not caused by fungi. It could be because you've got a plethora of fungal pathogens that might not be affected by itraconazole. They're all affected by different antifungal drugs. There might be resistance to the antifungal drugs that are being used. So it needs to be a combination, which is why I advocate for metabolic therapies, because fasting, hyperbaric oxygen therapy, all these therapies that Professor Seyfried is pushing forward are also antifungal in a way that they produce reactive oxygen species, which can kill the fungal pathogen within the cell, and is starving the cancer as well as the fungal pathogen of glucose.
One thing that Professor Seyfried did say was that they did the work to state that being in metabolic ketosis at 2.0 or below with your GKI measurement, that drug delivery on target is like tenfold. So I would absolutely advocate for any cancer patient that's going to take any sort of drugs whatsoever and then go into a hyperbaric chamber to make sure that they are in therapeutic ketosis and as low as possible. And if you are got a low GKI of 2.0 or below, before you go into the hyperbaric chamber, to take some other drugs like you mentioned that even further lowers blood glucose. And as Dennis Stacey said, when he had the mebendazole on board, he had the Don on board, he was in therapeutic ketosis, and then he went into the hyperbaric oxygen chamber for an hour and a half. That is a massive cancer-killing moment. And he said that he did that 4 times, and after four lots, he was NED. No evidence of disease. So taking all of the fuels away and killing the pathogens as well, because he's in therapeutic ketosis.
Yeah, well, that's it. There's a recent paper that came out talking about ketosis and how that affects pathogens within the body. They found that ketosis reduces the amount of pathogens that are present in the body. So it's anti-pathogenic, which is also beneficial for my theory as well. And just on one point on the pancreatic cancer, there's 2 studies. One a case study, and the case study was that a gentleman presented with pancreatic cancer. It was incurable, but he developed over fungal infection. So the oncologist provided him with itraconazole, an antifungal drug. He had that for 9 months, and I mentioned this on the Dave Asprey podcast.
Yes, I remember it. Yeah,
and that reduced his tumor to the point where it was actually resectable. So he had it removed, and he now survived an incurable cancer. And the oncologist stated that it was down primarily to the antifungal drug. So it shows that there's a benefit there. Also, there's other studies to show that when they were looking at the growth of pancreatic cancer and bacterial and fungal pathogens present within the tissue, they found that a particular type of fungal pathogen, Malassezia, was increased 3,000-fold in the pancreas. When they used antifungal drugs, the tumor reduced by 40%. When they reintroduced the fungal pathogen, the tumor started growing again. So it was the fungal pathogen that caused the tumor to grow. So they now know there's a direct correlation between the activity of the fungal pathogens and the increase in tumor growth. So yes, there's this major correlation that shows, especially in oral cancer as well. They highlight that candida essentially can explain at least 6 of the hallmarks of cancer in oral cancer, because they're able to assess the functionality of these fungal pathogens present within that type of cancer. So yes, there's a lot of evidence now suggesting that fungi have a role. And with my theory, it goes a step further to suggest that actually it could be that they are the direct underlying cause of the disease, but that it's very difficult to get rid of them. So we need to utilize antifungal therapies, off-label drugs that are also antifungal and targeting the metabolism of the cell. We also need to look at the microbiome to benefit the beneficial bacteria that are going to help eliminate or keep in control the fungal pathogens. We need to spiritually improve our mental health, exercise as well, and basically look after the terrain and attack this from a metabolic standpoint as well as an antifungal standpoint. I think that's the message I want to kind of push forward, is that on top of the metabolic therapies being pushed by Professor Seyfried, where there may be benefit, given that fungal pathogens seem to be controlling cancer, at least, it may be beneficial to include these fungal treatments as well. It's worth looking at.
I have read the paper that Professor Seyfried did with membendazole. He did a study on the mice using membendazole as the drug of choice, along with the diet. So the diet drug cocktail, and it wasn't quite as effective as the Don, but it was effective, and that's why he advocates for people that can't get a hold of the Don, that are self-medicating because they can't find a doctor to help them, to as part of their metabolic therapy, to use mebendazole and fembendazole. But in our interview, I did ask him if he had done fenbendazole, because obviously that's the particular drug that Joe Tipping's was his flavour. And he said they haven't yet. So from that, I take it that they will do another study on mice using fembendazole, and obviously Don as a control. So we need to see how that goes.
We do. There needs to be a lot more studies all across the board, really. But I'd just like to say as well, the thing is with the fungal pathogen is that if glucose isn't available, it will utilize glutamine, and it will convert glutamine into glucose. And if glutamine isn't available and the cell is able to absorb fat, it will use the glyoxylate cycle and transfer fat into glucose. So there's a huge chapter where I explain why cancer cells operate in a different way metabolically. It's because the cancer cell itself is working on autopilot. It wants to kill itself. It's programmed to kill itself. But the pathogen is preventing it from doing that. And what the pathogen is doing is it's absorbing all the nutrients within the cell. And so now the cell can only operate on autopilot. All it wants to do is create balance. So it's trying to restore glucose. It's trying to restore the glutamine. So it's trying to restore all the other elements of the nutrients in the cell that are now depleted. So you get this absorption of glutamine and glucose, but the fungal pathogen can then utilize those compounds for its own survival. So the cancer cell is effectively feeding the fungal pathogen.
You need to speak to Professor Seyfried, because he's got $100 bill for any student that can show him a cancer that can survive without the two fuels of glucose and glutamine. He's absolutely adamant that any cancer cell cannot survive on fatty acids.
Yeah. And I pretty much absolutely agree with that. I'm not saying that certain cancer cells just use fat, but it's a combination, and it's primarily glucose and glutamine.
Yeah.
But what I'm saying is, in any instance where glucose is reduced, the access to glutamine is increased or reduced, or the access to fat is increased, the fungal pathogen can adapt, which is why it makes it so difficult to kill cancer, because the fungal pathogen can adapt even if you do restrict glucose, because it will adapt to get the glucose from glutamine that's being upregulated in the cell.
Right, but not if you eliminate both glucose and glutamine.
Yes.
Right. Just great. We've got that buttoned off for the audience.
Okay. Yeah. Because the thing is, with the fungal pathogen, it's very difficult. It's a last resort to switch to the glyoxylate cycle and get fat it's much easier for the fungal pathogen to acquire glucose and glutamine, but it's a last resort. It's difficult for the fungal pathogen to obtain glucose from fat. So it's not something it can switch to very quickly necessarily. So if you are going to reduce glucose and glutamine, what you'll find is that actually the pathogen will become weakened enough for the immune system to deal with it, which is why it can't necessarily survive on fat.
Yeah. And if it has no fuel, then it'll die.
Absolutely. At the end of the day, the fungal pathogen becomes weak, and if the cell itself then can utilize its mitochondria or create free radicals to kill the fungal pathogen, then you're going to get death of the tumor as well as the immune system being utilized. But then that becomes a problem because a lot of the immune system uses glutamine and glucose in.
Yeah, that's hence the press pulse protocol.
Yes.
Press glucose continually and pulse the glutamine. And Dennis Stacey's protocol is actually on Met Cancer website, so it's there for any budding cancer patient to read exactly what he did and how he did it. Are you familiar with the work of Dom D'Agostino?
Yeah. Yes.
And the he literally got a atom microscope of some description. I don't think it was an electron microscope, but it was some very, very high-powered, multi-million-dollar microscope, and looked at brain cancer cells, glioblastoma cells, under the microscope when in hyperbaric oxygen, and they were literally exploding. And that's how come the professor recommends hyperbaric oxygen, because it as you say, increases ROS, the random oxygen species, and just literally blows them apart.
So what's interesting about that is the iron relationship to cancer. So generally, you have iron overload is only really associated with tumors because they can't store the iron effectively. Now, the issue is that fungal pathogens utilize iron. Iron is required in order to grow cells, essentially. It's like
Right.
rocket fuel to pathogens. Now, with the iron overload, you've got normally a release of iron into the tumor itself, where it should be kept under lock and key because it's so reactive. Hyperbaric oxygen therapy is great in the sense, and intravenous vitamin C works in this way.
Yep.
Where the peroxides react with the iron present within the tumor to cause the free radicals that are present. And those free radicals then go on, I argue, to kill or weaken the fungal pathogens. And that's right why they're antifungal in that sense. Others would obviously argue that they're going to cause damage to the cell and then the cell dies, which is also the case as well. But you have this outburst of reactive oxygen species because it's reacting with the iron that's present. It's almost like a targeted form of chemotherapy.
Yes.
I mean, chemotherapy works in a very similar way to that. We're told that chemotherapy works by damaging DNA, and then the cancer cell mutates, and then the chemotherapy no longer works because of the mutation. But actually, what happens is any toxin will go into the cell, will damage the cell, and initiate this reactive oxygen species event. Because mitochondria are becoming damaged, so they'll instigate this free radical response.
Right. Yeah.
Chemotherapy also works in this way by causing damage to the cell, which triggers reactive oxygen species. The only problem, the difference with hyperbaric and intravenous vitamin C is that chemotherapy damages all cells, where those other two just react to the iron
To the cancer
overload.
cells.
Only, yeah, to the cancer cells, because they're reacting to the iron overload. That's what makes them targeted. So you're not affecting healthy cells, which is why they appear beneficial. So
Yeah.
there
Yeah.
needs to be more research on this.
Yeah. So another thing for a cancer patient to add to their arsenal, intravenous vitamin C, prior to going into the hyperbaric oxygen chamber.
And
I
it
mean,
does need to be.
cancer doesn't stand a chance, really, does it?
Not well, no.
I
Not
mean,
if you can hit it
you
from a
know,
number of
when
angles.
exactly, and um, when when metabolic therapy becomes standard of care, we will see such a drop in deaths because people the whole industry will get excited about, oh, I managed this patient with this, and I managed this patient with this, and I managed this patient with this. But at the moment, we've got standard of care written in granite. Um, we need Moses to help us.
Yeah, we do. And I honestly think that oncologists will be, their job will be so much easier, and they'll be so thankful if they could utilize these metabolic therapies and actually see the benefit to their patients. I
Yes,
can imagine that would be such a relief.
yeah. One thing that Professor Seafried did say when he was first talking to the guys in Istanbul, Turkey, they read his book and decided to administer metabolic therapy with their patients, and he came back to him and was absolutely blown away by the efficacy of the treatments that they were doing. They were so used to treatments that were not efficacious that it blew them away. And and like he says, it works, and it does work, and it will work. But like I say, that's on the wall. It's a I get, that's that's on the wall. It's a disruption waiting to happen.
Hopefully,
And
hopefully.
that line there is where we are. That's where we are at the moment. And hopefully I'll start moving it across as we get more and more people. But I would like to talk to patients as well, but ones with a bit of weight on, like me, that can stand going doing a starvation for a week. But anyway, well, that's great, Mark. I think the next time we speak, I think we also should get Professor Seafried on here and have a three-way conversation and see what he has to say. I mean, hopefully he'll take what you've said on board and use all of his power and facilities to prove and disprove anything, and maybe um, we'll get even further understanding this dreadful disease.
Hopefully, yes. That would be fantastic to do that. I am working with scientists at the moment who we're working in, to try and establish some tests to test the theory. So we
Right,
are actually trying to see where it lies and if we can find particular metabolic combination antifungal therapies that would work. So we're in that process. So it would be
right.
great to talk to Professor Seafood. Absolutely. But we're also working in the background to try and test the theory to see if it has validity in a clinical setting.
Yeah, and I'll just sort of sit and watch and nod. you know. Anyway,
Well, I'm here to learn as well, and Professor Seafried, he knows his stuff. He's been doing this for a hell of a lot longer than I have. So yeah, he'll have insight that I won't have. So
yeah,
that'll be
yeah,
fantastic.
brilliant. All right, Mark. Well, thanks for that. Great to talk to you, and thanks for the education.
Take
Cheers,
care.
mate. Bye.
Bye.